Hi guys, welcome back to my channel. So in the previous video, we did question number 1 to 17 of exercise 5.1 of mathematics grade 12. And in this video, we're going to start doing question number 18 onwards. You must be noticing that things are a little bit different now. I thought of going for a more digital approach because the last time when I shot it, the lighting was a bit here and there in the video and it didn't look so well. I'm not sure if it was clear enough to you. So this time we're planning to go a little bit more digital. Drop in your feedback if you want me to improve on any of the things that I'm doing in this video. Okay, so let's start question number 18. What does question number 18 say? For what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is lesser than or equal to 0 and 4x plus 1 if x is greater than 0. We have to check if this function is continuous at 2 points. One is when x is equal to 0 and the other one is when x is equal to 1. Right, so let's begin. First we are going to check the function is continuous at x is equal to 0. Right, now what are we going to do? At x equals to 0, look at the left hand side and the right hand side of x equals to 0. When x is lesser than 0, there is a different function. When x is greater than 0, there is a different function, right? So we are going to use the concept of left hand limit is equal to right hand limit is equal to the function. When do we say that a function is continuous? We will say that the function is continuous at x is equal to 0 when LHL is equal to RHL is equal to f of 0, right? This is the rule that we are going to follow in this question, correct? So now to do this, we have to say what is LHL and what is the RHL. What is LHL over here? We will say that when limit x tends to 0 minus f of x is equal to limit x tends to 0 positive f of x is equal to f of 0. This is what we need to prove, right? So let's go step by step. Let's take 0 minus first. So we're gonna check LHL at x tends to 0 minus and RHL at 0 plus, right? Let's shoot. Limit x tends to 0 minus f of x, which means limit h tends to 0 f of 0 minus h. Now 0 minus h becomes f of minus h. That means in the function that I'm going to choose, instead of x, I need to put minus h. Which function am I going to choose when x is lesser than 0? I'm going to choose this function, right? So let's take this function and instead of x, wherever there is x, I'm going to put minus h. So now this becomes limit h tends to 0 lambda into wherever I have x square, I'm going to put minus h square minus 2 into minus h. And now I'm going to simplify this by putting h equals to 0 wherever I have an h. So that becomes lambda into 0 square minus 2 into 0 which is equal to 0 on the left hand side. On the right hand side again I have limit x tends to 0 positive f of x, which is equal to limit x h tends to 0 f of 0 plus h, which again becomes equal to limit h tends to 0 f of h. So when x is greater than 0, I'm going to use this function. So this becomes equal to limit h tends to 0 for h plus 1. Now wherever there is h, I'm going to substitute 0. That means it becomes equals to 4 into 0 plus 1. That is 0 plus 1 which is equal to 1. Now observe carefully, what is the left hand limit? It is 0. And what is the right hand limit? It is 1. So it is very obvious that the function is not continuous. Left hand limit is not matching the right hand limit. So what are we going to say? For any value of lambda that is an element of R, f is not continuous at x equals to 0. Alright, now let's move on to x equals to 1. Now let's start evaluating the condition when x is equal to 1. Is the function continuous at x equals to 1? Now, one thing that you need to understand over here is that for solving the continuity and proving that the function is continuous at x equals to 1, you don't need to do the whole procedure all over again, right? Continuity at x equals to 1. Think about it. Look at this function. F of x is equal to 4x plus 1 for all the values that are greater than 0, right? For everything that is greater than 0, f of x is equal to 4x plus 1, right? And that is a polynomial. So anything, any value that is greater than 1, the function is going to be 4x plus 1, which is a polynomial. And what do we know that when a function is polynomial? It is continuous, right? So when x is equal to 1, what will be my function that I will be taking? Oops, sorry. F of x is equal to 4x plus 1. This is the function for all values that are greater than 0, right? So if you think for values lesser than 1, also this will be the function because x greater than 0 or that is lesser than 1. So for values lesser than 1, this is going to be the function. For values greater than 1, also this is going to be the function. And for values equal to 1, also this is going to be the function. Since this is a polynomial, it is going to be continuous. So what can we finally say? Since this is a polynomial, the function is continuous at x equals to 1. And we are done with 18th question. Okay. So now moving on to the 19th question. Show that the function defined by g of x equals to x minus greatest integer x is discontinuous at all integral points. Here, greatest integer x, which is an x in square brackets, denotes the greatest integer less than or equal to x. So how do you read this? How do you read this? X in a square bracket, it's called greatest integer which is less than or equal to x. They have given you the explanation for this. It is called the greatest integer less than or equal to x. Before we move on to the question, let me give you a little bit of a concept as to what is the greatest integer, right? So that your understanding is clear and it helps you understand how to solve the question better. Okay, so now let's assume that I have a simple number 5. Right? Now this number 5, if I have to write it in integer format, obviously it's going to be the same. It's going to be 5, right? Okay. Now I want to decrease this value of 5 by a little bit, right? I just want to decrease, I want to write a value that is a little lesser than 5, but not reaching to 4, little lesser than 5. So I will write a number. Let's say that number is 4.999, right? If I have to write this 4.999 in an integer format, how will I write it? I will write it as 4, correct? Okay, let's go back to 5. Now I want to write this 5 by increasing this value of 5 a little bit. Okay, if I increase the value of 5 a little bit, but I don't want to reach to 6, how will I write it? 5.999. If I have to write this 5.999 in integer format, how will I write it? I will write it as 5. Okay, so this gives you an idea how is the integer format of a number that is lesser than, little lesser than 5, a little more than 5. Okay, now let's say that instead of 5 I have a number c. Okay, so c in normal integer format is also going to be c. I'm using the same concept that I have used over here, right? Now, if I have to decrease C a little bit, suppose I have to do C minus H. Okay, so what will be the integer format of a number that is C minus H? See, it's gonna be C minus 1. Why did I say C minus 1? So if 5 is C, what is 4? 4 is C minus 1. Exactly. So if I decrease the value of C by a small quantity h, the integer format of this becomes C minus 1. Right? Now, if I increase the value of C by a small number h, what do I get? Again, it's 5. So the integer format of this becomes C. Right? So when you are solving this question, any place that you have bracket C under your limits, when you open the limits, you are going to put, instead of that, you're going to put C. If you have square brackets C minus H and you want to open the bracket and put the value for it, you will put C minus 1. Okay. And if you have C plus H and you want to open the bracket and put the limit, you will put C. Clear? This is how the integer, greatest integer concept works. Okay, so if you want to remember this, easy way to do it is draw the number line. This is C, this is C minus 1, and this is C plus 1. How did I get this? Imagine drawing a number line 5. What comes before 5? Comes 4, and what comes after 5? 6. So this is 5 minus 1 and this is 5 plus 1. Same concept, C minus 1 and C plus 1. Okay. So every time you have C minus H, you're going to put C minus 1. Okay. And every time you have C plus H, you're going to put C. Clear? So this is how you have to remember in the terms of a number line, and this is the concept of the greatest integer. Now let's move on to solving the question. So first of all, when is a function continuous? A function is continuous when limit x tends to c minus f of x is equal to limit x tends to c positive f of x is equal to f of c. So again, we're going to check the LHL and the RHL values. And here you have g of x, right? So let's start. Limit x tends to c minus g of x is equal to, you change this to h tends to 0, g of, you have c, correct? So c minus h, correct? Now in the function, wherever there is x, you have to replace it with c minus h. So this becomes limit h tends to 0, c minus h minus bracket square brackets, because here you have normal x and here you have in the square brackets. Now what did I tell you? Every time you have c minus h, you're going to replace it with c plus h when you have to remove the square brackets. So now this becomes limit h tends to 0, c minus h minus, now you're going to put normal brackets. What are you going to replace it with? C minus h is equal to c minus 1. When you open the brackets, the sign is going to change. That becomes equals to limit h tends to 0, c minus h minus c plus 1. Right? So c and c gets cancelled out over here. And then when you put the value of h as 0, 0 plus 1 is equal to 1. So that is your left hand limit. Again, on the right hand limit, what happens? limit x tends to c positive g of x. So that becomes equals to limit h tends to 0 g of c plus h. Now in the function, we are going to replace it with c plus h minus, square bracket c plus h. So c plus h gets replaced by c. So I'm going to write this as c plus h minus c. Again, c and c gets cancelled out. I'm sorry, I forgot to put the limit over here. Limit h tends to 0. When you put the value of h as 0, you get the value as 0. So we have to show that the function is discontinuous at all integral points. Since our left hand limit is 1 and our right hand limit is 0, we have proved that g of x is not continuous. LHL is not equals to RHL, and g of x is not continuous at all integral points. Okay, simple. Okay, now this question is a fairly simple one. The function is not given in a complicated format, as I have taught in my last video. When the functions are given to you in a straight line format, you go for the simpler formula. What is the simpler formula for a function to be continuous? Now you have to prove the continuity at x equals to pi. So if a function has to be continuous at x equals to pi, what formula am I going to use? Limit x tends to pi f of x should be equal to f of pi. Here we are not going to do LHL and RHL because we don't have a different value on the left hand side and the right hand side of this point, the point of continuity, correct? So let's directly shoot at the question. So we have to do this part first and this part first. So limit x tends to pi f of x. What is my f of x? Limit x tends to pi. Here I don't need to do h tends to 0 because we are not decreasing the value uh, of the value x by a small amount h, or no, we are not increasing the value of x by a small amount of h. We are finding the value of x at pi. So we will just write it as x tends to pi, and I will write my function inside this x square minus sine x plus 5. Now wherever I have x, I need to substitute it by pi. So I'm going to remove the limit minus sine pi plus 5. Now what is the value of sine pi? Pi square is going to remain pi square. I'm going to not solve it further. Sine pi is 0 plus 5. So the value over here becomes pi square plus 5. This is my left hand side, right? Now just draw a line and then we hop on to the right hand side. What's my right hand side? F of pi. So f of pi means I need to directly substitute the value of the function as pi. So f of x is equal to x square minus sine x plus 5. So f of pi will be equal to pi square minus sine pi plus 5. Again, pi square minus 0 plus 5. Why am I saying this? Because sine pi is equal to 0. So I have pi square plus 5 on this side and pi square plus 5 on this side. So this is equal to this, and therefore I can say that LHL is equal to RHL. Therefore, the function f of x is equal to x square minus sine x plus 5 is continuous at x equals to pi. As simple as that. Okay, so 21st question is also really simple. Now 20th question and 21st question can both be solved in the same way, but I have taught you two separate methods to do both so that you know that they can be solved in two different ways. 21st question I'm going to solve by a different approach, which is simpler, just so that it doesn't get really difficult for you guys to prepare for your exam. You don't waste time in a lot of difficult complications. So let's hit the easiest way to do this. Now, the first question is a f of x is equal to sin x plus cos x, right? Now, if I have to explain it in a very layman term, in the beginning of the chapter, what did we learn? A function is continuous if you can draw the function without lifting your pen up from the paper. Now, if I have to draw the graph of a sine function, how do I draw it? I'm going to draw it like this, right? Do I need to lift the pen when I draw it? No, it is continuous. Similarly, a cos function is also continuous. Cos function is also in the similar manner. You draw it without lifting your pen. So both the functions are continuous, right? Sin x is also always continuous. Cos x is also always continuous. Before you solve these kind of functions, you really need to be acquainted with the algebra of um, continuous functions. To give you a short brief, let me write down. Let me tell you some points. So sin x is always continuous, cos x is always continuous, polynomials are always continuous, right? Constant functions are also always continuous. So in this chapter, these are the 4 or 5 things that we are going to be using continuously. So it's important that you know that constants are continuous, polynomials are continuous, sin x and cos x is also always continuous, right? So what I'm going to do is I'm also going to use algebra of continuous functions in this question as well. So let's see how it goes. So f of x is equal to sin x plus cos x. What I'm going to do is I'm going to take p of x as sin x and I'm going to take q of x as cos x. Right? Now we know that sin x and cos x are both continuous functions, right? So I can say that since sin x and cos x are continuous functions, p of x and q of x are continuous at all real numbers. Okay? Now, if p of x and q of x are continuous, that means f of x is equal to p of x plus q of x, right? So, by the algebra of continuous functions, if p of x and q of x are continuous, then p of x plus q of x, which is equal to f of x, is also continuous for all real numbers. Therefore, f of x, which is equal to p of x plus q of x, is also continuous for all real numbers. Therefore, f of x is equal to sin x plus cos x is continuous for all real numbers. This is the first part. Now for the second part, what are you going to do? Instead of plus, there is a minus sign. So I'm just gonna replace all the pluses with minuses and the rest of the part remains exactly the same. So here we have a minus p of x minus q of x and it is continuous for all real numbers. That's your second question. Third question, again the same thing. Instead of a minus or a plus, you have multiplication. Dot means multiplication. This, I'm sure everybody knows this. So we have a dot. So p of x into q of x, p of x into q of x, sin x into cos x is continuous for all real numbers. Right? Simple, easy. Next question. Okay, all right. Now I'm just gonna skip question number 22 for time being, and we'll do it towards the end. It's a little long. Might do it in this video, might do it in the next video. Let's hop on to question number 23 for now. So here you see the function f of x is equal to sin x by x if x is lesser than 0 and x plus 1 if it is greater than 0 or equal to 0, right? So what are the three cases we are looking at over here? Case number 1 is when x is lesser than 0. Oh my god, sorry. So case number 1 when x is lesser than 0. Case number 2 when x is equal to 0, and case number 3 when x is greater than 0, right? So we are going to work out these cases one by one. Let's start with case number 1. This case number 1. Case number 1 is when x is lesser than 0. All right. So when x is lesser than 0, what function are we going to use? Sin x by x. So f of x is equal to sin x by x, right? Now we know that sin x is continuous. Same concept that I taught in the last question. If I take p of x as sin x and q of x as x, this is a basic polynomial and this is a trigonometric function which is sin x. This is continuous, this is continuous. So if p of x by q of x is continuous, then f of x is continuous. Therefore, we can say that since sin x is continuous and x is also continuous, therefore f of x is continuous for x lesser than 0, right? Now, what is the case 2? Case 2 is when x is equal to 0, right? Okay, so now we are going to do LHL at x tends to 0 minus. So we have limit x tends to 0 minus f of x, which is equal to limit h tends to 0 f of 0 minus h, also equal to limit h tends to 0 f of minus h. All right. So again, which function am I going to use when x is lesser than 0? Sin x by x. So here, this becomes limit h tends to 0 sine of minus h by minus h, right? So sine of minus h by sine of minus h is minus h, correct? So that's gonna be limit h tends to 0 minus h by minus h, which is equal to 1. Now moving to x tends to 0 positive. Limit x tends to 0 positive f of x is equal to limit h tends to 0 f of 0 plus h. Limit h tends to 0 f of h. When the function is greater than 0, the f of x is x plus 1. So limit h tends to 0 h plus 1. Now substitute the value of 0 over here. This becomes equals to 1. So LHL is equal to RHL. There is also a third part which we do, which is f of c, right? So limit x tends to 0 f of x. At x equals to 0, again it is x plus 1. So here we don't need to change to h tends to 0. I've explained this before. X plus 1. Wherever there is x, I'm going to replace it with 0. So this becomes equals to 0 plus 1, which is 1. So I can say that LHL is equal to RHL is equal to f of 0, or limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. Therefore, function is continuous at x is equal to 0. The third condition we will check is at x greater than 0. at x greater than 0, what is the function? F of x is equal to x plus 1. You can see that this is very evidently a polynomial function. So we can say that f of x is a polynomial. Therefore, f of x is continuous at x greater than 0. So for all the three values of x lesser than 0, greater than 0, and equal to 0, f of x is continuous, right? Okay, the next question, f of x is equal to x square sine 1 by x if x not equals to 0 and 0 if x equals to 0. Now, do you see we don't have a greater than or a lesser than over here? We have x not equals to 0. What does that mean? Imagine that this is your number line, right? You have 0, value of x equals to 0. So this will be the values that you will be considering when you have x not equals to 0, right? For x not equals to 0, you are considering values on the left side of x and on the right side of x, but not x equals to 0. That means when I say values lesser than x is also x not equals to 0, and values greater than x is also x not equals to 0. So the question is fairly easy. We have two conditions when x not equals to 0. When x not equals to 0, f of x is equal to x square sine 1 by x, right? Now x square, is always going to be continuous, right? It's a polynomial. X square is continuous, and sine 1 by x is also continuous. Man, this continuous. Okay. Therefore, f of x is also continuous. Continuous for x not equals to 0. The second case we have to evaluate is at x equals to 0. So whenever it is x equals to 0, usually you do left hand side and right hand side. But what is given to you over here, a direct value of the function is given, which is equal to 0. Correct? So let's see if our left hand limit and right hand limit match up to 0. So we are going to switch to LHL RHL view of it. Limit x tends to 0 minus f of x is equal to limit h tends to 0 f of 0 minus h, limit h tends to 0 f of minus h. When the value is lesser than 0, which are we going to take? X square 1 minus x square sine 1 by x. So limit minus h square sine 1 by minus h, right? Okay, so now how do we solve this part? Sine 1 by minus h. Okay, now you know that sine theta will always be between minus 1 and 1. That means sine theta is a definite value which comes between minus 1 to 1, right? So if sine theta comes between minus 1 to 1, I can also say that sine 1 by minus h will also come between minus 1 and 1, right? That means sine minus 1 by h is a finite value. It is a value, it is a constant value. So what will I do? I will replace sine 1 by h, 1 by minus h with k. So over here, I'm going to write limit into k. Now I'm going to put the value of h as 0. When I put the value of h as 0, this becomes 0 into k, which is equal to 0. Same procedure I'm going to do over here also. Limit x tends to 0 positive f of x, limit x tends to 0 f of 0 plus h. Limit h tends to 0 f of h, which means, again I'm going to take this function, limit h tends to 0, h square sine 1 by h, replace this with k, limit h tends to 0, h square into k, put the value of h as 0, 0 into k, which is equal to 0, right? And at x equals to 0, what is given to us? At x equals to 0, limit x tends to 0 f of x. This is directly given to us as 0. Therefore, LHL is equal to RHL is equal to f of 0. Function is continuous at x equals to 0. So the next question, you can see that the conditions are kind of similar to the previous one, x not equals to 0 and x equals to 0. So let's hit it case by case. First case, when x not equals to 0. When x is not equals to 0, f of x is equal to sin x minus cos x. So what do we know? We know that sin x is continuous, and we also know that cos x is continuous. Therefore, f of x is continuous for x not equals to 0. Second case, when x equals to 0, f of x is equal to minus 1, and we are going to see this case by case for LHL, RHL, and f of. Okay, so I just wrote the basic steps just to save some time, and now I'm going to directly substitute. When x is lesser than 0, we're going to take this function. So limit h tends to 0, sine of minus h minus cos of minus h. So we know that sine of minus x is equal to minus sine x, right? And cos of minus x is equal to cos x. So cos x h, right? And then we substitute the value of h. So minus sine 0 minus cos 0. Sine 0 is 1, sine 0 is 0 minus 1. That is equal to minus 1. Same thing on the right hand side. Limit h tends to 0. Greater than 0 also we are going to use this one. Sin h minus cos h. Sin 0 minus cos 0. 0 minus 1, which is equal to minus 1. And then we already know that limit x tends to 0, f of x, the value given to us is minus 1. Therefore, we can say that LHL is equal to RHL is equal to f of 0. Therefore, function is continuous. Okay, now question number 26 to 29 are of a little bit of a different type. Here they are telling you that the function is already continuous. They are already telling you that the function is continuous, and you have to find the value of k on the function. So what do we know when the function is continuous? What is our primary formula? LHL is equal to RHL is equal to f of x or f of c, right? So now using this, we want to try to find the value of k. You know that all these years when you've been studying, you know that every time you want to find the value of a particular alphabet in algebra, right, they always give you a hint which you can equate, and you can find out the value of that particular a letter like A, B, C, K. Every time you have to find this, you know in mathematics that there will be something that you will have to equate to get this. So here what are we going to do? We are going to do the left hand limit and right hand limit and f of c, and we will equate it and we will find the value of k. right? Now looking at this question, the value of f of c is very easily given to us as 3. So I'm going to do either LHL or RHL. I'm going to find either one of them and then I will equate it with f of c, right? Either I will equate LHL with f of c or I will equate RHL with f of c. All right. So let's get on to the question. So I'm going to do the RHL part of it. Limit x tends to pi by 2 plus f of x is equal to limit h tends to 0 f of pi by 2 plus h, right? Which is equal to limit h tends to 0 when x is greater than pi by 2. We are going to use this, right? So k cos pi by 2 plus h divided by pi minus 2 into pi by 2. Now this obviously needs a little bit of a simplification. So you know that cos 90 minus theta, 90 plus theta is what? Minus sin theta. So limit h tends to 0, k minus sin h by pi minus, okay, this is pi plus h. So when you open the bracket, it becomes minus 2 pi by 2 minus 2h. Limit h tends to 0 minus k sin h divided by, so this 2 and 2 gets cut. Again, pi minus pi will get subtracted. What is remaining in the denominator? Minus 2h. So minus and minus gets cut over here. What are you left with? Limit h tends to 0 sin h by k sin h by 2h. So you see this k by 2, it's a constant. So I'm going to take it outside. K by 2, limit h tends to 0 sin h by h. Substitute the value. That is equal to, when you substitute the value of h as 0, what happens? You get 1, and then finally you get the value of RHL as k by 2. Okay. Now, what are we going to do? We have to equate it to f of c. F of c, the value is 3. So you know that RHL will be equal to f of c in this value. So what are we going to do? Equate k by 2 equals to 3. The value of k becomes equals to 6 after solving the equation. That's about it. Next question is also of the same type. So again, we can either do the LHL or the RHL and try to solve the question. This time I'll do the LHL part. So LHL is equal to RHL is equal to f of c, since the function is continuous. Now if I have to solve the LHL, limit x tends to 2 minus, because we have to find the value at x equals to 2. But for x, limit h tends to 0 f of 2 minus h. Limit h tends to 0. What function will I take when x is lesser than 2? Kx square. So k into 2 minus h the whole square. All right. Now what am I going to do? I'll substitute the value of h as 0. So this becomes k into 2 minus 0 the whole square, which is equal to 4k. This is my left hand side value. RHL I don't need to do really, because I'm going to directly equate LHL to f of c. Now what is my value for f of c? It is 3. So let me equate that. 4k is equal to 3. K is equal to 3 by 4. That's the value of. Again, question number 8 is similar. What is our golden rule? LHL is equal to RHL is equal to f of c. So again, I'm going to do LHL. Limit x tends to pi minus f of x is equal to limit h tends to 0 f of pi minus h. So when x is lesser than pi, which function am I going to choose? Kx plus 1. So limit h tends to 0 k into pi minus h plus 1. Right? Again, substitute the value of h as 0. And what do you get over here? K pi plus 1. Okay. Now, at in this case, f of c is not going to be beneficial for us to do. So I'm going to do RHL value. Okay. Because f of c at is also equal to kx plus 1. So RHL is equal to limit x tends to pi plus f of x, limit h tends to 0 f of pi plus h, limit h tends to 0. What is the value when you take x is greater than pi? It is cos pi plus h. Now substitute the value of h as 0. What are you left with? Cos pi. Right? Now what is the value of cos pi? It is minus 1. So if this is your equation number 1 and this is your equation number 2, you will equate both of them. K pi plus 1 is equal to minus 1.